Have you ever wondered what happens to a star when it runs out of fuel? Today, we're diving into the explosive science of supernovae, and it's more than just fireworks in space. A supernova is the explosive death of a star, and it's not just any explosion. It is the most powerful and dramatic explosion in the universe. It's the final farewell of a giant. In just seconds, a single star can shine brighter than an entire galaxy. And the energy it releases? It's almost unimaginable. But not all stars go out with a bang. Only the massive ones, stars at least 8 times heavier than our Sun, are capable of this dramatic exit. Stars spend most of their lives fusing hydrogen into helium. This releases the light and heat we see. Inside a star, there's a constant battle between gravity, which wants to crush everything inwards, and the outward pressure created by nuclear fusion, where lighter elements like hydrogen are smashed together to create heavier elements like helium, releasing enormous amounts of energy in the process. This fusion is what keeps the star shining. Stars spend most of their lives fusing hydrogen into helium, but when the hydrogen runs out, the star begins to fuse heavier elements, helium into carbon, carbon into oxygen, and so on, until it reaches iron. And here's the twist. Fusing iron doesn't release energy, it consumes it. The star can't hold up its own weight anymore. And gravity wins. As a massive star runs out of fuel in its core, it can no longer produce enough outward pressure to counteract gravity. The core collapses in on itself in a fraction of a second. This implosion creates a shockwave that blasts the outer layers of the star outwards in a spectacular explosion. A supernova. But a supernova isn't just destruction, it's creation. The explosion scatters heavy elements out into space. And this is super important because these heavy elements, things like carbon, oxygen, and iron, are the building blocks of new stars, planets, and even us. You could say we're all made of stardust. And as for what's left behind after the supernova explosion, it depends on the star's size. Sometimes it leaves behind an incredibly dense object called a neutron star, so dense that if you had a teaspoon of neutron star material, it would weigh billions of tons on Earth. Other times, if the original star was massive enough, the collapse can continue, forming a black hole, an object with gravity so strong that not even light can escape. So the next time you look up at the stars, remember that every atom in your body, your bones, your blood, your breath, was forged in a supernova billions of years ago.